Despite heavy regulation and constant monitoring, complex industrial systems routinely fail. In just a 4-month span in 2008, the Food and Drug Administration and the National Highway Traffic Safety Administration issued hundreds of product recalls across highly controlled sectors. Between 2000 and 2007, commercial aviation recorded over 80 major accidents or incidents. The outcomes of these breakdowns are a matter of life and death. Organizations quarantine the damage, patch the immediate error, and resume operations. Because they leave the underlying mechanism completely intact, the exact same failures repeat. Modern quality management systems like the ISO 9001 standard mandate tracking and resolving errors. But these frameworks provide zero cognitive diagnostic guidance on how to locate a cause. Companies confuse the administrative tracking of a problem with the deductive reasoning required to solve it. The statistician W. Edwards Deming observed that survival is not mandatory. Markets punish organizations that rely on administrative checklists to solve operational failures. To stop recurring errors, organizations must abandon the paperwork exercise and construct a logically deductive root cause analysis engine. Root cause analysis, or RCA, is a structured method of identifying the underlying systemic reasons a problem occurred. Failures have 3 causal layers. The first tier is the symptom, a signal something is wrong, like a defective part. Next is the physical cause, the immediate reason, like a damaged machine component. These chain together. A forklift struck it because floor lines wore away. Quarantining the defective part is containment. Repainting the floor lines is remedial action. Neither action prevents the floor lines from fading again in the future. The final tier is the system cause. This is the latent policy or procedure failure allowing the physical chain to occur. The organization has no scheduled process for maintaining lines. True root cause analysis only occurs when the investigation reaches this foundational layer and forces a permanent change in organizational behavior. Failures rarely exist in linear isolation. They manifest through complex causal topologies. Because each time why is asked, there are many possible answers. Take a bookstore shipping error. The incorrect shipment could be driven by an order entry mistake, a computer algorithm error, or a manual packaging failure. These are independent causes. Attempting to investigate and solve all independent causes simultaneously disperses analytical energy and produces shallow results. Investigators must apply the Pareto principle, focusing on the vital few causes over the trivial many. Filter independent pathways to isolate the single node with the highest frequency. Conversely, combination causes require multiple variables to be true simultaneously. A localized fire requires both the inherent sparks of a welding operation and the variable presence of flammable materials. Identifying the exact topology of the failure is a strict prerequisite for deciding where to allocate limited corrective resources. Organizations face a structural bottleneck when tracking these problems. The metric for this is corrective action density, calculated by dividing the total number of corrective actions initiated by the total number of employees. If a 250-person company initiates 400 formal corrective actions in a single year, the system is in a state of overload. When investigators are overwhelmed by volume, cognitive diagnostic rigor drops to 0. The system processes paperwork but fails to correct anything. Blindly initiating a formal investigation for every observed failure guarantees that the most critical, latent system causes will be ignored. The structural solution to density overload is a ruthless pre-investigation filter designed to separate minor anomalies from systemic threats. This non-conformity risk matrix plots occurrence frequency against potential impact. Low-risk problems receive localized correction and are database tracked, deliberately preserving resources. Conversely, high-risk recurrent failures are routed to a dedicated team for full systemic root cause diagnosis. This filter is the protective barrier of the RCA engine. It ensures advanced diagnostic energy is spent exclusively on high-leverage organizational failures. Once a problem passes the filter, it enters a structured logic engine, such as the 10-step DO IT2 model, replacing flat administrative checklists with rigorous deduction. The first 5 steps form the find it phase, forcing investigators to drill down into the causal network. It's an iterative process. Investigators constantly loop through data collection and hypothesis testing until the precise system cause is isolated. This rigorous testing stands in sharp contrast to the linear, sign and file timelines demanded by basic compliance software. Effective problem solving is an active, continuous refinement of the problem definition itself. Relying on reactive guessing to treat physical symptoms is a shotgun approach. It wastes organizational energy on surface-level repairs. True diagnosis requires a rifle approach, a singular, hyper-focused deductive strike on a verified system cause that unlocks the real issue. Escaping the cycle of recurring failures requires treating root cause analysis as a hard technical discipline, rather than a paperwork exercise. By mapping causal topologies and fiercely protecting diagnostic resources through triage, an organization transitions from administrative compliance to actual system immunity.